I will be giving an overview on ICE Vision. ICE Vision is an agnostic computer vision framework. I started this project with my good friend Lucas 15 months ago, and the project went really exponentially. It started with the very basic requirement to just develop a data API to help people to get in the object detection. And we noticed that object detection is notoriously difficult when it comes to try to pick a model and to train your own data. So the objective is to democratize computer vision and to make it really easy to use for people in different areas, and that way they don't spend their time in figuring out how to run a model and how to hook up the different parts of the algorithms and the training group and so on, and just to focus on collecting data and just training their data. So before diving in, I would like just to cover the different tasks that are supported in ICE Vision. So up to now, we are covering object detection. So for those who are not familiar with, it's a bit different than classification. So the idea is to detect objects and to also assign labels to different objects. Like here, we are using a toy data set called fridge objects. And we also cover instance segmentation, which is quite similar to object detection. It adds more like the mask or the contour of your objects. So it's more precise than just drawing a box around your object. Then we have key points, and key points, they have many applications that we can apply them in different use case and industry and so on. And we also cover semantic segmentation. I think this one is quite popular because of self-driving vehicles, and it's relatively easy in comparison to instance segmentation or object detection. And lately in ICE Vision, we introduced hybrid models, and the idea is to have a multitask training. And by multitask is, I mean, we can train different tasks at the same time. So here we have object detection, classification, and segmentation. And the idea is to have just one backbone, and then we plug to those backbones the neck and also different heads where we can have object detection, classification, and segmentation. In this example, we can see that we are doing object detection by detecting people, and drawing the box around them, and also classification. And here the classification consists of detecting, for example, what kind of lightning, and is it indoor, outdoor, and so on and so on. And this this framework is going to be extended to other tasks, and probably to time series, and also to NLP and so on. And to our knowledge, ICE Vision is the first framework that support out of the box these kind of hybrid models. So to go back to why we decide to develop ICE Vision, I'm going to describe a use case that will sound very familiar to you. Let's say we have, as an engineers, we would like to solve a problem, and to solve it, we have to use an object detection. We have to train an object detection model. So we will face the issue to decide which framework do we have to use? So let's pick PyTorch because it's the one that is most popular these days. But our plan is also to support later TensorFlow and MixNet. So in Torch Visions, we are familiar with the PyTorch. We have Torch Vision, and Torch Vision supports different object detection models like fast RCNN, and also mask RCNN, Keypoint, and RetinaNet lately. But then we are limiting ourselves just to those 3 or 4 models. So if the competitor decides to use another model, and even if we start our project like 3 months before them, we might be like lagging behind if they pick up like a more capable models. And as an example, we have MM detection. MM detection, it's a very interesting project from MM Labs, and in their library, they cover over 50 models, and they provide over 300 checkpoints, which means like over 300 pre-trained models that we can use out of the box. And we also have the choice to choose EfficientDet. EfficientDet shows like great results in both academia and industry. And there's also YOLO V5 that is quite popular because of the fact that it's very light and it trains fast, and also it's very suitable to be used on mobile devices, for example. And then at certain point, we could decide we would like to change our models, even if we have some from MM detection. The fact that Ross Whiteman has his library called TIM, he provides over 270 models with pre-trained models and checkpoints and so on. So we might be interested in creating like new models by combining those from Ross and those from MM detection, for example. Then once we decide which models we are going to use, we might facing the choice between either using, for example, the training loop from MM detection, or the training loop from PyTorch Lightning, or FastIA, for example, that provides like a very good default setting and all kind of tricks to facilitate training our model. We also have like more curated libraries that are publicly available. So at this point, we might wonder, so what if we don't have to choose between those different libraries? And what if we could just have access to all of them or a part of them? And the answer is Ice Vision. This is what we build. What we build is a framework that bridges all those libraries and which eliminates like the hard choice to choose between those models and between different training loop and so on. So basically, Ice Vision, what it is, it's a unified computer vision framework that deals with data, the model, and the training at the same time. So to give you a sense how it's unified, this is the kind of code snippet that any Ice Vision user will use. And it's very standard, like a code snippet. And it always follow like these steps. The first step is to choose the model. So here we choose a model, for example, from MMDet. We are choosing RetinaNet. And which backbone we are using? We are using here a ResNet 50 FPN. So once we choose our model, all what we have to do is to load our data to parse it. So out of the box, we support both COCO annotation and VOC annotation, but we also support custom parser. So if you have like your data that is organized differently than COCO and VOC annotation, you can just create your parser, and it takes like a couple of minutes to create. We have templates, and we have so many examples where people can just adapt. And because at the end of the day, those data format, they are quite similar. They can be a CSV file or text file or something like that. And then in Ice Vision, we support transforms. Out of the box, we use augmentation, but we have like all the infrastructure to support other libraries than augmentation. And then we create our data set, and we use the transform here if we are interested in, for example, data augmentation while we are training our model. And then we can just create our data loader. All this part is very common, and it's not dependent on the model or on the the library that we are using. And then once the data loader is ready, we can just create our model object here. So it's the same thing here. Model type, it's a RITNA, so it's a RITNA. Create a model, use a backbone that is a ResNet 50 FPN, and then we need the number of classes here that we get at this step. And then we can create our learner. I'm using the FastIA example. It's very simple. So we have a learner, we instantiate the learner, and then all we have to do, this is like an optional step to detect which learning rate is suitable for our training. And then once we figure out which learning rate, like in this example, it will be 0.01. And then we start our training. Fine tune means just train first, freeze the head and train, and then unfreeze for the first epoch, and then unfreeze everything and train the model again. So to illustrate more how easy we can swap or switch different models that are provided by different libraries. So here we have 4 examples. The first one is the MMDET that I just show here, but we can switch to another model from Torch Vision. So this one, it's the same. It's a RITNAnet, but it was implemented in Torch Vision, and they use this backbone. So the name is a bit different, but it's basically the same architecture. And we don't need to remember all those names. Everything that we provide, there is an auto completion. So as soon as you start typing models, then we will have like the choices between MMDET, Torch Vision, ROS, and so on and so on. And then the third model is an efficient DET. And in the efficient DET, we have so many backbones. So to illustrate here, we are using a Light 0, which is a very small backbone. So it can be trained very, very fast. And the last one is a YOLO 5. And even with the YOLO 5, we support 8 backbones. They are from small to large and extra large. And lately, a couple of weeks ago, they released 4 new ones. And we are already supporting them. And then in some cases, there are models that needs to have the image size. So we add just the image size here, and that's it. And all this model, so is, for example, here, all I have to do is just decide to which model I want to use. So I can switch selection from 0 to 3, and then I can switch from one model to another. So since the beginning of the project, we had a vision to try not just to focus on training, but to create a framework that covers all the steps that we, or the pipeline that is used in industry. So collecting the data, preparing the data, exploring and deploying and monitoring and so on. So to collect the data, we provide like the standard parser. We add a new parser every time. For example, there are some annotation tools, and then we try to cover their parser, their format out of the box. We have also a dashboard for Ice Vision that was developed by one of our contributors, Frederick, and it helps to explore the data and so on and so on. And training, I just showed the example. Deploying, we have many examples also how to connect the trained model, either to showcase our examples, like using Gradio or Streamlit or so on, and also how to use it with like a web API and so on. For monitoring, we support 1DB, weights and biases. And so here's what I wanted is just to highlight the unique features. It's like a summary of what I just said. So Ice Vision provide like a data curation. So we auto-detect like the mistakes, the most common mistakes. And those are really roadblocks to train a model. And we were experiencing that situation while we were training our own model. And then we realized that it's better to try to have an API, a data API that helps the user to auto-fix or detect those before even starting to train, because very often if we have errors in our data, those we will pop up just during the training, and it's a waste of time. So we provide an API that does that. And so we have a dashboard for Ice Vision that was built by Frederick. And as I said, it helps to explore the data, the distribution of our boxes, and so on and so on. And it gives really like a nice overview of how our boxes are distributed, and before we train and after we train and during inference and so on. We have pluggable transforms, and as I said, we support argumentation out of the box, and there are also more libraries that will be supported in the future. We have access to literally hundreds of neural net models, from MM detection, from TIM, from torch vision, efficient data, and so on. And we have access also to different training loop. For now, we support PyTorch Lightning and FastIA, but we plan also to expand to other highly curated training loop libraries. We also support the multitask training, as I showed the illustration at the beginning. So the whole idea is to be able to combine object detection, segmentation, and classification. And the literature and the experience showed that by combining those tasks at the same time and training them at the same time, you will get better results than trying to have like separate models that are trained separately. So Ice Vision is built around a community, and we have some really high, very talented core developers who are helping us to expand and to improve the framework. And we are expanding on a regular basis with the idea that we would like to support more and more tasks and more library. So we have core developers that are expert in their domain, and in different domains. Some people they were working on audio, some people on video, and some people have background in NLP and so on. So the fact that we have like a very diverse team, it helps us to improve our framework and to expand very quickly. Also, from day one, we want to build a community around Ice Vision, because the success of this framework will depend on the adoption, on its adoption. So from the beginning, we put some efforts to create like a very welcoming community, and to welcome both beginners and intermediate and expert users. So Ice Vision was, we started the project in May, or I think May or June 2020, and we released our first version in September, end of September 2020. And around that time, we had just 10 members. By mid-December, we reached 100, and now we are around 400 members. So it's expanding very quickly. So this is the documentation that we provide. We have a documentation for a different version that we released, and so it's a framework that is well documented, and the Ice Vision users very often they highlight the fact that we provide like a very extensive documentation, and we provide examples and access directly to a Colab notebook where people can just open a notebook and they can play with the example that we provide. Like this one, I just started it earlier. And so basically, it's the same thing that I was presenting earlier. Here we can choose a different model and different backbone and so on. And then we can train our model. Let's say, yeah, it's still on. So here, this is what I mentioned early. This is like an optional step where we can have like a suggested learning rate. This is provided by the FastAI library, and lately PyTorch Lightning, they followed the same path, and they also are providing an LR find for their framework, and that gives you like the different learning step. Here, it's because I just trained my model, so it's suggesting another learning rate, but usually if it's the first training, you will end up with something similar. Hopefully it's something like this. So we can see that the learning rate here is the minimum, it's around this, but you already have this, like the suggested one that you should try to use out of the box. And for this example, we can see that we reach a precision of almost 90% after just 20 epochs, and this is because we are using transfer learning in this case. So it trains pretty fast. So, and this is our Discord forum. So we are using Discord as a forum, and here we have the list of all our projects that are in progress. So we have the TIM and MM detection integration, the multitask metrics. We want to provide our own metrics, and we have audio and so on. There's a project around deployment about small object detection. This I tweeted about it and shared on LinkedIn lately. And just to give some tips and tricks for people who are interested in detecting small objects. We also have a channel for Kaggle. So we have people who are interested in competing in Kaggle, and they use Ice Vision as a framework to train their model there. And as I said, we have really a very welcoming community, and they are very helpful, and we welcome everybody. So if you are interested in computer vision, either you are a beginner, whether you are a beginner or intermediate or expert, I'm sure that you will find the forum very helpful, and you can ask your question there, and you can also share your knowledge. And the whole idea is to help each other to advance in this field, and to make sure that we can build something that can be useful, and where we can build like meaningful application in computer vision.
What is the deployment framework? Once the model is trained, is it exporting PyTorch or TensorFlow models?
It's exporting PyTorch. Well, the PyTorch models, and then you have the options of exporting using Onyx. And when the model is Torch scriptable, we can export it as a Torch script. And Torch script, it's for example, if you want to use it in mobile apps, for example. So, but the most common one and the easiest way to share it is through Onyx, because Onyx is like more common, and most of the models, they support Onyx. And with Torch script, it's less supported. There are models that are not Torch scriptable.